Good morning, everyone. So last week we went over functions, rate of change, and how to write linear equations. Today we're going to be reviewing and going more in depth of what linear functions are. So our topic of today is linear versus nonlinear functions. Our learning target. Today I can identify if a function is linear by determining if it can be written in a form y equals mx plus b. Properties of linear functions. Linear functions always form a straight line when graphed. If you look at the first four letters of linear, you can see the word line. So you always associate linear functions with the word line. Straight lines. They always form a straight line when graphed. The second bullet point, linear functions can be written in the form y equals mx plus b. We went over this last Thursdays when we was writing linear equations, where m is our rate of change and b is our initial value, and x and y are our independent and dependent variables respectively. Our third bullet point, linear functions have a constant rate of change. So when you're given a table and you're trying to determine if it's a linear functions, you see if the table has a constant rate of change. Is it growing at the same rate throughout the whole table? Properties of linear functions. The fourth bullet point, x and y both have an exponent of 1. So if you see the equation y equals 2x plus 4, these two variables both have an exponent of 1. It can't have any other exponent. So say you're giving the equation y equals x squared. Since the exponent is 2 next to x, it is not a linear function because the exponent is not equivalent to 1. X is never in the denominator of a fraction. So say you're giving the equation y equals 1 over x plus 2. This is not an example of a linear function because x is in the denominator. And the last bullet point, x and y are not an exponent. So say you're given the equation y equals 2 to the higher power x. This is not an example of a linear function because it's actually an example of an exponential function, which my algebra folks should remember. All right, on to problem number 1. Identify one linear equation and one nonlinear equation from the list below. State a reason why each you identified is linear or nonlinear. So first things first, I'm going to see what I am given. So I am given 4 different equations. And the question is asking me to to identify one linear equation and one nonlinear equation, and I have to state a reason why, meaning I have to justify my answer. So for the linear equation, I'm going to choose the equation y equals 2x minus 5. I'm going to go back on my list to see which one matches y that is a linear function. So I can look at the second bullet point and I see that linear functions can be written in the form y equals mx plus b. So I'm going to use that to justify my answer. So y equals 2x minus 5 is linear because it is written in the form y equals mx plus b. All right, nonlinear equation. Let's see. I guess I can choose equation number 3 because y equals x squared plus 6. I'm going to go back to my list of properties and I'm going to choose x and y both have an exponent of 1 as my justification. So y equals x squared plus 6 is not linear because x has an exponent of 2. And since it has an exponent of 2, it is not written in the form y equals mx plus b. Therefore, it is not a linear equation. Besides the 2 examples I chose, can you guys think of any other equations that are nonlinear or linear? You could jot it down on your notes, or you can keep it in your head. Now on to problem number 2. So here's your problem number 2 of the day. Be sure to answer this in your classwork. Okay, bye guys.